On September 2nd, 2003, scientists were searching for proof of modern human migration. Instead, they uncovered a skeleton just over 1 meter tall. The skeleton was found in a cave on the island of Flores, Indonesia. The skeleton had a brain smaller than a chimpanzee's. Her features and the stone tools found with her upended what scientists thought they knew about human evolution. Was this Hobbit an extinct human species, or did some survive undetected for thousands of years? Answers begin at the moment a team realized they had found not modern human bones, but something stranger. At dawn, on September 2nd, 2003, a team of Australian and Indonesian researchers entered Liang Bue Cave on the island of Flores, expecting to find traces of early modern humans. Instead, their trowels uncovered a nearly complete skeleton embedded in the cave floor. The bones belonged to an adult female who stood 1.1 meters tall. Her brain case held only 426 cubic centimeters, smaller than that of a chimpanzee. Field notes from that morning described the bones as soft and fragile, more like damp paper than stone, and the team dried each piece with gentle air currents before it could be lifted. The initial surprise deepened as more bones emerged, each confirming the skeleton's small size and unusual proportions. Within days, the remains were catalogued as specimen LB1. The discovery team included Peter Brown from the University of New England, and he soon played a central role in analyzing the find. By early 2004, after months of comparative study, Brown and his colleagues formally named the new species Homo Floresiensis. The announcement sent shockwaves through the scientific community, and journalists worldwide seized on the nickname the Hobbit to capture public imagination. Liang Bue quickly became a focal point for paleoanthropology. Field diaries from September 2003 document the painstaking process of excavation. The diaries note the unexpected depth of the burial layer and the absence of modern human artifacts in the immediate vicinity. The skeleton's age and context pointed to a lineage distinct from both modern humans and known archaic species. In the months that followed, researchers realized that the Flores skeleton was not an isolated anomaly, but evidence of a population with its own evolutionary history. The moment of discovery at Liang Bue marked the entry of Homo Floresiensis onto the scientific map, and it raised new questions about human origins and the diversity of our ancient relatives. LB1's anatomy presented a challenge to every established category in human evolution. The mandible showed no sign of a chin, the forehead sloped back sharply, the skull vault was low and rounded, the shoulders were hunched forward and narrow, shoulder blades sat high and close to the neck. The arms were long in proportion to the torso, the hands were short but robust. Curved finger bones hinted at climbing ability, the feet measured nearly as long as the femur. They had broad, flat soles and stubby toes, features that made the nickname the Hobbit more than a media invention. Osteologists noted the bones were unusually soft and unfossilized. Researchers often described the texture as like wet blotting paper. Each fragment required slow air drying before it could be handled or studied. This requirement complicated every step of the excavation. By 2015, partial remains of at least 15 individuals had been uncovered at Liang Bue. All showed the same suite of traits. Those traits included small stature, small brain, and primitive skeletal features. None matched the proportions or bone structure of local pygmy populations. This finding ruled out a simple case of insular dwarfism within Homo sapiens. In the same sediment layers as the bones, archaeologists recovered stone tools, flakes, blades, and cores. These tools demonstrated a level of sophistication once thought beyond a hominin with such a small brain. The tools showed signs of deliberate shaping, edge retouching, and use wear consistent with butchering and woodworking. Analysis of the lithic assemblage revealed patterns of manufacture and discard that paralleled those found in much larger-brained hominins. The direct association between these sophisticated tools and the primitive skeletons forced a re-examination of long-held assumptions about the relationship between brain size and technological ability. The puzzle of Homo Floresiensis was no longer just about bones, but about culture and cognition as well. In December 2004, Teuku Jacob, a senior Indonesian paleoanthropologist, entered the National Research Center in Jakarta and removed almost all of the Liang Bue fossils, including the LB1 skull, without the discovery team's permission. Jacob insisted on re-examining the remains, arguing that LB1 was not a new species but a microcephalic modern human For 3 months, the fossils were kept in his custody. The discovery team was left in the dark, and formal requests for their return went unanswered. When the bones finally came back in February 2005, Peter Brown and Mike Morwood found that the jaw had been sliced by a mold-making knife. The chin was snapped and reattached at the wrong angle. The pelvis was shattered beyond repair. The damage was irreversible. Morwood described the scene as sickening. Correspondence between the institutions quickly turned hostile. The dispute drew in Indonesian authorities, who responded by banning all access to Liangbua Cave for outside researchers until Jacob's death in 2007. The scientific community watched as the fate of the fossils shifted from discovery to damage control. Years of research were threatened by a single act of academic rivalry. Flores sits east of the Lombok Strait, a deep water channel that even at the lowest Ice Age sea levels separated it from the rest of Southeast Asia. No land bridge ever connected Flores to neighboring islands, so any ancient arrival meant crossing open ocean. It was an unlikely feat for early hominins. Once there, isolation shaped every living thing. The island became a laboratory for evolution. Stegodon florensis insularis, a dwarf elephant barely taller than a human child, shared the forests with Komodo dragons that grew to monstrous size. Prey species shrank while predators grew larger, a classic case of island gigantism and dwarfism. Homo Floresiensis hunted juvenile stegodon and giant rats, both abundant in cave deposits. Archaeologists found bones of these animals in the same layers as stone tools and traces of fire, including charred bone fragments and ashy sediments. Those associations confirm that the small hominins controlled fire for cooking and possibly for defense. Resources were always limited. With few large prey and unpredictable rainfall, survival depended on adapting to the island's narrow ecological margins. The ecosystem itself set the boundaries for what was possible, making every species on Flores vulnerable to even small changes in climate or food supply. Two rival theories have shaped the debate over the origins of Homo Floresiensis. One school of thought argues that the species descended from Homo erectus, the first hominin known to have reached Southeast Asia over 1 million years ago. Proponents of this view point to the established presence of erectus on nearby Java and suggest that a small population rafted to Flores, where isolation and limited resources drove their bodies and brains to shrink through insular dwarfism. This model fits with evolutionary patterns seen in other island species like the pygmy stegodon and giant Komodo dragons found on Flores. A competing hypothesis proposes a much deeper ancestry. In 2017, Debbie Argue at the Australian National University led a comprehensive cladistic analysis comparing 133 skeletal traits from Homo Floresiensis with a wide range of fossil hominins. Argue's study found that the wrist, foot, and shoulder bones of the Flores hominins more closely resembled those of early African species such as Homo habilis or even Australopithecus rather than any Asian Homo erectus. This result challenged the long-standing assumption that all Southeast Asian hominins shared a common erectus ancestor. Instead, it suggested that the ancestors of Homo floresiensis might have left Africa before Homo erectus did, possibly over 1.75 million years ago, carrying primitive skeletal features into the deep isolation of Flores. Archaeological finds at Matamenge, 74 kilometers east of Liangbua, have added weight to the early dispersal model. In 2016, researchers uncovered fossil teeth and a partial jaw dated to around 700,000 years ago. These remains matched or were even smaller than those from Liangbua, indicating that the body size of Flores hominins remained stable for at least 600,000 years. Stone tools found at nearby sites date back as far as 1.02 million years, marking one of the oldest records of hominin technology in island Southeast Asia. The evidence from Matamenge and Liangbua points to a lineage that arrived early, adapted quickly, and then persisted in isolation for hundreds of millennia, far from the evolutionary mainstream. In 2016, Thomas Sutikna and his colleagues published new stratigraphic data from Liangbua that forced a complete overhaul of the timeline for Homo floresiensis. Their analysis pushed the youngest skeletal remains back to between 60,000 and 100,000 years ago. Stone tools last appeared around 50,000 years ago. This revision ended the idea that the hobbits survived alongside modern humans for thousands of years. Their disappearance instead aligned with the earliest evidence for Homo sapiens on Flores. The next breakthrough came from Michael Gagan's team at the University of Wollongong. In December 2025, they released a paleoclimate study using stalagmite samples from Liang Luar Cave, a few hundred meters from Liangbua. By measuring magnesium to calcium ratios and oxygen isotopes, they reconstructed rainfall patterns for the period when Homo floresiensis vanished from the archaeological record. The data showed a steady decline in mean annual rainfall, dropping from about 1,560 millimeters to 990 millimeters between 76,000 and 61,000 years ago. Summer rainfall between 61,000 and 55,000 years ago fell to 450 millimeters, less than half of modern levels on Flores. Faunal records from the same interval show a sharp decline in stegodon, the primary prey of Homo Floresiensis. Riverbeds near Liangbua became seasonally dry, reducing access to water for both hominins and their prey. Gagin's team concluded that progressive aridification placed the entire ecosystem under stress. Shrinking resources likely forced Homo Floresiensis to abandon Liangbua and may have driven the species to extinction. The revised chronology and the new climate data together point to environmental collapse as the main cause of the disappearance of Flores' small-bodied hominins. The question now is whether any trace of them survived beyond the cave, hidden in the forests of Flores, or remembered in local stories. Gregory IV arrived in Flores in 1984, drawn by stories that local people told about creatures living in the island's forests. Among the Leo community in the eastern highlands, accounts of Laihoa surfaced repeatedly. These accounts described small, bipedal beings covered in hair, with faces that blended human and ape. These accounts came from farmers, hunters, and elders, none of whom had heard of fossils or foreign scientists. The details were consistent. The creatures stood about 1 meter tall. They walked upright. They kept to the deepest parts of the jungle. Some villagers described seeing them at dawn or at dusk. Villagers said the creatures moved quickly through the undergrowth. Others remembered finding footprints. The footprints were bare, broad, and flat, unlike those of any animal they knew. Forth spent decades listening, recording, and cross-checking accounts. He was careful to separate rumor from direct observation. He noted that stories about Laihoa were known long before the discovery at Liangbua. In 2010, a Leo man described stumbling upon a corpse in the forest. The man said it was not a child, but a small adult with long arms, short legs, and a flat face. Several family members examined the body and confirmed the details independently. The man said it had hair all over, but not as much as a monkey. He said its face was almost like ours, but the mouth stuck out and there was hardly any neck. No photos were taken and the body was left where it was found. The story spread quickly through the village. Other reports stretched back to the 1960s and the 1970s. In these accounts, Laihoa were seen carrying food. They were sometimes traveling in pairs. They always avoided direct contact with humans. Lao people insisted that these creatures were real, not spirits or legends. The phrase repeated most often was that they are scared of us and we are scared of them. Forth's field notes capture the sense of mutual avoidance. Humans and Laihoa shared the same forests, each keeping their distance. Over 30 years, he gathered more than 100 testimonies. Some described live sightings. Others described remains of a being that fit no known animal. Through these voices, the folklore of Flores preserves a memory that sits uneasily between myth and possible history. 50,000 years separate the last known bones of Homo Floresiensis from any living witness. For most scientists, this gap is decisive. No fossils, no DNA, and no credible artifacts have surfaced from the forests of Flores in all the decades since the original discovery at Liangbua. Excavations elsewhere on the island have failed to reveal even a tooth or a fragment of bone younger than 50,000 years. Yet the interior of Flores remains one of the least explored regions in Southeast Asia. Dense montane jungles, steep volcanic ridges, and hundreds of unmapped limestone caves stretch from west to east. Many of these areas have never been systematically surveyed by paleoanthropologists. Some remain inaccessible for months at a time due to weather or a lack of roads. New technologies are starting to change the search. LiDAR, a laser-based mapping system, can scan through thick forest canopy and reveal hidden cave entrances and ancient landforms in hours. Environmental DNA, known as eDNA, allows researchers to sift soil and water samples for genetic traces left by living or recently extinct mammals, including primates. Thermal drones can sweep the jungle for heat signatures, picking up animals that rarely emerge into the open. So far, none of these tools have been deployed in a targeted search for relict hominins on Flores. These tools have transformed wildlife surveys elsewhere in Indonesia. Skeptics argue that given the long fossil silence, the odds of survival are vanishingly small. The absence of evidence is not evidence of absence, especially on an island where so much terrain remains unexamined. The question of whether Homo Floresiensis still walks the forests of Flores is not settled by folklore or by wishful thinking. It is a testable hypothesis, waiting for the right tools, the right questions, and the next generation of explorers willing to look beyond the known. Even now, vast stretches of Flores remain unsurveyed by science. As satellite data confirms, more than half the island is dense, unexplored jungle, potentially hiding secrets older than modern humanity. Whether the hobbits vanished or persist in memory alone, their story reminds us that the fossil record is never truly closed. Discovery only ends when curiosity does. What do you think? Could something still be out there?